Okay, in this video we're going to do a brief introduction into some fundamental trig identities. We have kind of referenced these reciprocal identities in a previous video, but we have these reciprocal identities that basically tell us that certain trig functions are reciprocals of other trig functions. So secant is the reciprocal of cosine, cosecant is the reciprocal of sine, tangent is sine divided by cosine, and cotangent is reciprocal of tangent, which means that it's going to be cosine divided by sine. I just flipped this fraction, right? The reciprocal. Okay? So, and then we've got this main Pythagorean identity. Now there are some more Pythagorean identities, but the main one that we're going to use a lot is that cosine squared plus sine squared is equal to 1. Now, in a video on the construction of the unit circle and why the coordinate points are the way that they are around the outside of the unit circle, we broke down our angles into special triangles, thinking about like 45, 45, 90 triangles or 30, 60, 90 triangles. And what we came up with every time was that the cosine was, if the cosine is the x, that means that whatever that x distance was of our triangle, that's the cosine value. The y was the sine value, and our hypotenuse every time was 1 on the unit circle. So no matter which angle we were looking at, we always had this triangle that we could come up with where we had an x coordinate, a y coordinate, our hypotenuse was 1. And so if you know that cosine is x and sine is y, and you know the Pythagorean theorem, then this should make a ton of sense, right? It's just the x distance squared plus the y distance squared is equal to 1 squared, or cosine squared plus sine squared is equal to 1. Okay? So, so that's where that comes from. Okay? Cosine squared plus sine squared equals 1. I do want to make another note. When you see cosine squared written like that, cosine squared of t means the cosine of the angle squared. Okay? Now, you might say, well, why don't you just write cost squared? Well, if you just put the square on the outside of the t here, it appears as though the angle is what's being squared, just the t value. We want to make sure that we're squaring the trig function. So the way that they do that is they'll put the square after cosine. Let's say cosine squared of t. Notice that that just means this. Okay? So we're going to use that fact when we look at this problem here. So it says that the cosine of the angle t is 3/5. Okay, now we're clearly not talking about one of our special angles on the unit circle, because if we know that cosine is the x coordinate, none of the x coordinates around the outside of our circle are 3/5. Okay, so I'm not looking at a special angle. However, this angle is some angle that would be represented on the unit circle. Okay, it's just not one of them that we have listed. So, if the cosine of the angle t is 3/5, and t is in quadrant 4, so our angle ends up in quadrant 4, find the values of the other trig functions at the angle t. Okay, so what I want to do is I want to think about, do I have some kind of relationship with these identities that gets me from cosine to another trig function? Okay, so there are a few of them that involve cosine, but I want to make sure I pick one that only has cosine and one other trig function. So I could do secant, or I could use this Pythagorean identity and solve for sine. My suggestion to you is always going to be, if you have cosine, use your Pythagorean identity and get sine. The rest of them are easy if you do that. Likewise, if you're given sine, go ahead and use the Pythagorean identity to find cosine, and then you can find the rest. So I'm going to start with my Pythagorean identity. Cosine squared of t plus sine squared of t is equal to 1. Now, if I know that the cosine of t is 3/5, that means that this cosine is going to be replaced with 3/5. So 3/5 squared, right? I'm squaring cosine. So 3/5 squared plus sine squared of t is equal to 1. And so what I should be able to do at this point in time is I should be able to solve for sine. So 3/5 squared would be 9/25. 9/25 plus sine squared of t is equal to 1. I'm then going to subtract the 9/25 over to the other side of the equation. Okay, so we have sine squared of t is equal to, now what is 1 minus 9/25? Well, in order to do that, we could think of 1 as being 25/25. 25/25 minus 9/25 would give me 16/25. And then I need to get rid of my square, so I'm going to take the square root of both sides. And that's going to give me that the sine of the angle t is equal to 4/5 or possibly negative 4/5. So how do I know which one it is? That is where this part where it tells me which quadrant I'm in is important. All right, when we do the square root, we could say plus or minus. However, it's only going to be one of the two. So if we're in quadrant 4 is down here. Sine is our y value. So that means that this is going to be negative because y values are negative in quadrant 4. So I know that the sine of the angle t is negative 4/5. Okay, so there's one more that requires a little bit of work, and that's tangent. Once I get tangent, I can get the other 3 really quickly. The tangent of the angle t is equal to, so what's it say about tangent? Tangent is sine divided by cosine. So I know that sine, so I'm going to go ahead and write that. Sine t divided by cosine t. I know that sine is negative 4/5. I know that cosine is positive 3/5. That was given to me. So the tangent is simply going to be negative 4/5 divided by 3/5. So we can use our shortcut here that if the denominators are the same, they're going to cancel out. I'm just going to get this fraction here. So tangent of the angle t is negative 4/3. Okay, now as promised, the other 3 should be pretty quick. Sorry. Secant. Okay, so what do we know about secant? Secant is the reciprocal of cosine. So if cosine is 3/5, secant is 5/3. Easy as that. Cosecant. Cosecant is reciprocal of sine. So if sine is negative 4/5, cosecant is negative 5/4. And cotangent, our last of the 6 trig functions, cotangent is reciprocal of tangent. So if tangent is negative 4/3, then cotangent is negative 3/4. So again, my suggestion would be use your Pythagorean to find either sine or cosine, whichever one was not given. Once you have that, find tangent. Once you have sine, cosine, and tangent, the other 3 should be really quick to come up with. Okay. So what does that tell us? That tells us that we don't even know what the angle t is. It's some angle that ends up in quadrant 4. So thinking about that in terms of degrees, I know it's going to be somewhere between 270 degrees and 360 degrees. I know it's not going to be one of these special angles because I didn't get these values for sine and cosine. Okay, but I just know that angle t is some angle down here in quadrant 4. Okay, and what we found was the trig functions evaluated at that angle. The cosine of the angle, again, I don't know what the angle is, but the cosine of that angle is 3/5. The sine of that angle is negative 4/5, and so forth. Okay. All right. Next question is to write tangent in terms of cosine, where t is in quadrant 3. So what does that mean? Well, for tangent, what I know about tangent is that it is sine divided by cosine. So what this question is asking us to do is it's saying I don't want more than one trig function on the right side. I want to say tangent is equal to only stuff that involves cosine on the right side of my equation, which means I need to get rid of sine. I need to be able to write sine in terms of cosine so that I can replace that with some stuff that involves cosine. So what I'm going to do is I'm going to think, how can I replace sine with cosine? I got to come up with some identity that involves sine and cosine, and that means I'm going to use my Pythagorean identity. Okay, so just out to the side here, I'm going to say cosine of t plus, cosine squared of t plus sine squared of t is equal to 1. And what I'm going to do is I'm going to solve for sine t so that I can replace sine t in this fraction, and I would only have cosine left. So when we get to the very end of this, we're only going to have cosine stuff on the right side of this equation. So what I'm going to do is I'm going to solve for sine. So that means I'm going to subtract the cosine squared. So sine squared t is equal to 1 minus cosine squared t. I want to get rid of the square. I'm going to take the square root. So the sine of the angle t is equal to the square root of 1 minus the cosine squared of t. Now, just a quick heads up, you cannot take the square roots of the 1 and the cosine separately because we have a subtraction problem in here. So I can't split that up and say just 1 minus cosine t. It just has to be the square root of 1 minus cosine squared of t. It has to stay that way. Now, do remember that when you do take a square root, again, you should put plus or minus in front. So that's where this comes in handy. We're in quadrant 3. So what I just did was I solved for sine in quadrant 3. Sine is the y-coordinate. This should be negative. Then the idea is, since I solved for sine, what I'm saying is sine is equivalent to negative the square root of 1 minus the cosine squared of t. That's going to go in up here. So what we're saying is that the tangent of the angle t is equal to negative the square root of 1 minus cosine squared t all over cosine t. So the directions were right tangent in terms of cosine, which means that I have tangent, and what it equals is stuff that only involves the trig function cosine. Okay, so that problem's a little bit more involved. The important part of this video is that given one of your trig function values, you should be able to find the other 5 trig function values. That's more important. Being able to manipulate an equation to where I only have one trig function on the right is another skill to have, not as important as this top skill.